Why we dream, the science of our nightly hallucinations. Okay, let's just dive right into this explainer by throwing you into a scenario that, well, you probably know all too well.
Picture this. Every single night, right from the comfort of your own bed, your mind completely rewires reality. It takes you on these bizarre, incredibly lifelike adventures. And the crazy part? You don't question it, you just experience it. But really, why? Why are our brains fundamentally wired to put us through these intense nightly hallucinations?
I mean, you know the feeling, right? You're a teenager again, back in high school, you're wandering these busy, endless hallways, squinting at the numbers on the doors, but they're just gibberish. Suddenly it hits you, you totally forgot to go to history class all year. Then boom, the hall's empty out, it's pitch black, you sense something behind you, you look over, and there's this faceless figure coming right at you. You try to run, but you are literally glued to the floor. And right as this thing reaches you, gasp, you wake up. That terrifying, completely absurd journey felt incredibly real in the moment, didn't it? Well, if you add up all those nightly adventures, we spend roughly 7% of our entire lives, which averages out to about 6 full years, completely immersed in these surreal, sometimes magical, sometimes downright terrifying worlds. 6 years. The architecture of sleep, lifting the hood on our nighttime biology. So, human sleep is basically a cyclical journey. Throughout the night, your brain cycles through these distinct phases roughly every 90 to 120 minutes. You start out in NREM, that's non-rapid eye movement sleep, drifting from that light doze in stages 1 and 2 all the way down into the deep, restorative, slow-wave sleep of stage 3. But it's right after this deep sleep that you enter the truly fascinating phase, REM, or rapid eye movement sleep. This right here is where the real magic and the real madness actually happens. To put that into perspective, if someone were to wake you up during one of those earlier NREM stages, there's only about a 42% chance you'd remember dreaming anything at all. But if they wake you up during REM sleep, you've got a massive 82% chance of recalling a vivid, lifelike dream. And get this, the deeper into the night you go, the longer those REM cycles become. Which brings us to a really strange biological paradox. REM is literally called paradoxical sleep for a reason. If we hook you up to an EEG, your brain activity looks like it's running a marathon. I mean, it perfectly mimics being wide awake. But there are two massive catches here. First, your prefrontal cortex, the part of your brain responsible for logic and reason, completely shuts down. That's exactly why you don't question the absolute absurdity of your dreams. Second, your brainstem triggers something called REM atonia. It literally paralyzes your physical body. Why? So you don't jump out of your bedroom window thinking you're skydiving. Decoding our dream content. What we see when our eyes are closed. Now, while our dreams obviously draw heavily from our personal daytime lives, researchers have actually found that certain bizarre themes are practically universal across the globe. Almost everyone knows the feeling of falling, or being chased, or having your teeth suddenly just crumble out of their mouth. Or, oh, how about the classic humiliation dream? You're standing at the altar on your wedding day, everyone turns to look at you, and you suddenly realize you're wearing swim trunks and snorkel gear instead of a tuxedo. But despite how funny that might sound when we talk about it the next morning, the actual emotional tone of our dreams is incredibly telling. Back in the 1940s, a psychologist named Calvin S. Hall started collecting this massive database. We're talking over 50,000 dream reports. And looking at his data provides a pretty surprising counter-narrative. Anxiety and negative emotions actually outweigh positive, happy dreams by a significant margin. Yep, even for healthy, perfectly happy people, our nightly mental movies lean really heavily towards stress.
Theories. Why do we dream? From ancient deities to modern neuroscience.
Historically, humans believed dreams were deeply profound. The ancient Sumerians and Greeks, they saw them as literal messages from the gods or even visions of the future. Fast forward a bit to the early 20th century, and you've got Sigmund Freud arguing they were the repressed secret wish fulfillments of our unconscious minds. But modern empirical science, it looks at this entirely differently. Today, dreams are framed either as biological byproducts of a sleeping brain or as highly evolved survival mechanisms. Let's break down the leading modern theories here. First, there's the threat simulation theory. This suggests our brains are basically running an internal VR training simulator, safely exposing us to dangers, like avalanches or predators, so we're fully prepared in our waking life. That perfectly explains why dreams are so negative, right? On the flip side, the activation synthesis theory argues that, well, dreams are completely meaningless. They're just your brain desperately trying to organize random static firing from the brainstem into some kind of coherent story. And then you have the continual activation theory, which simply says the brain generates this imagery just to keep its engine idling so it doesn't shut down entirely.
But honestly, the most compelling data out there points toward memory consolidation. Think of dreaming as organizing your brain's hard drive. During the light sleep of NREM, your brain is processing declarative memory, so the raw facts and events from your day. But during the vivid dreams of REM, your brain is processing non-declarative and emotional memory. It's solidifying the physical skills you learned and processing the complex emotions attached to your recent memories, basically deciding what files to keep and what to throw in the trash.
When dreaming goes rogue, glitches in the sleep matrix. We've all heard the old myth of a demon sitting on someone's chest in the middle of the night, right? Well, science demystifies this perfectly as sleep paralysis. Remember REM atonia, that mechanism we talked about that paralyzes you so you don't act out your dreams? Sleep paralysis happens when your conscious mind wakes up, but your body's REM atonia is still locked in. You are literally caught in a terrifying glitch between the dreaming world and the waking world, fully paralyzed and often hallucinating the lingering contents of your dream right there in your bedroom. Now, imagine the exact inverse of that scenario. This is known as REM sleep behavior disorder, or RBD. Here, the brainstem completely fails to paralyze the body during REM sleep. Because our dreams are so often negative or action-packed, these individuals will literally act out their dreams. We're talking fighting imaginary battles in their bedrooms, leaping out of bed, and honestly posing a serious danger to themselves and their partners. So these two frightening sleep disorders are exact neurological opposites of one another. In sleep paralysis, your mind is wide awake, but your body is stuck fast asleep. In REM sleep behavior disorder, your mind is fast asleep and dreaming, but your body is fully awake and moving violently. It's wild when you think about it.
And there's another severe glitch in this system, narcolepsy. Due to a specific chemical imbalance, specifically a lack of a neuropeptide called orexin, the brain mistakenly activates that REM paralysis right in the middle of daytime wakefulness. Intense emotions can suddenly trigger this paralysis, causing sudden muscle weakness or total collapse. It completely blurs the distinct biological boundaries between our waking and sleeping mechanisms.
Taking control, lucid dreaming, hacking your own hallucinations.
This brings us to a really fun topic, lucid dreaming. This is the phenomenon where you suddenly become consciously aware that you are immersed in a dream while the dream is actively happening. Instead of just being a passive observer, your prefrontal cortex sort of flickers back on, and you wake up inside the dream itself, gaining the ability to actually control the narrative. And remarkably, this isn't some science fiction concept. It was scientifically validated in a lab back in 1975, using tracked eye movements. So how on earth do you achieve this? Well, the most proven method is called reality checking. Basically, you train yourself to perform a routine action every single day, like checking the time on your watch, and consciously noting the realistic expected result. Because our daytime habits tend to bleed into our dreams, eventually you're going to check your watch in a dream. But in the dream, the numbers will be absurdly distorted. Noticing that exact distortion, that's the trigger that suddenly sparks lucidity. Finally, we have to touch on the persistent illusion of prophetic or precognitive dreams. You know the drill, you dream of an old friend and they literally call you the very next day. It feels like absolute magic. But from an empirical standpoint, this is usually just our subconscious mind picking up on subtle daytime cues to predict logical outcomes. Pair that with self-fulfilling prophecies and heavy confirmation bias, where we obviously remember the one dream that came true and completely forget the thousands that didn't, and the illusion of precognition is pretty easily explained. Look, we spend over a third of our entire lives asleep, engaging in this incredibly complex biological sorting mechanism that keeps our minds sharp, emotionally balanced, and prepared for reality. The fact that this whole process is wrapped up in such profound, terrifying, and just straight-up bizarre nighttime theater makes it one of the greatest enduring mysteries of human biology. So as you power down tonight, it begs the ultimate question. What entirely new reality is your brain preparing to simulate for you tonight?